Welcome back. In the last two videos, we learned about data types. Now the question is why we learn data types. So in this topic, variable declaration, you will get the answer that why we learn data type. Now consider a situation whenever you get a problem statement, what you do? You write a solution for it, right? Now this solution is basically a program written by you. Now what happens? This solution may have some requirement of values, may have some requirement of initial values that will be supplied by the user. And after manipulating those values, applying some formula, applying some logics, you get the final result, right? This result is then displayed on the screen, and that is what an output is, right? Now what happens? These values supplied by the users, the intermediate results of our solution and the final result need to be stored in the memory of computer. And here comes the role of variable declaration. Variable declaration is simply a statement by which we tell an interpreter that what type of value will be stored in memory, and accordingly we reserve the space in memory for those values and give it a name. That is, we declare a variable, and this is done by making use of the data type we have learned in the previous sessions. Unlike any other languages, in Python we do not require to write some complex syntax to declare a variable. It is very simple here. Just what we have to do is simply assign the value to a variable. Just like this. Simply give a name of a variable. Of course, the name should be a proper name. It should not be any keyword. It should not be a name that is already being used by the Python. It should be a proper name that makes the programmer understand that exactly what type of variable and what it is used for. And just assign a value to it. Whatever the value you want, you can assign. It is very much simple here in Python, right? So what we have to do is simply name a variable and assign a value to it, and Python interpreter simply takes care of rest of the things. The moment we assign the value to a variable, that variable is declared implicitly, and it is meant to store the type of value we have assigned, right? Means the moment this line will execute, what will happen? Python will understand that this is a variable and is storing this type of value, right? So here we can say that variable declaration and assignment in Python, of course, variable declaration and assignment is complementary to each other. We cannot declare a variable without assigning a value to it. Just look here an example. I have given the name of a variable as name, and the value assigned here is of a string type, that is Yash. Now what will happen in memory? A reference will be created, and the name of that reference will be name in this case. It will be pointing to a location in memory where the value Yash is stored. Look here. Here the value Yash is stored in a block, and this block is created in memory of a computer, that is in main memory, that is RAM. And this memory is being pointed by the reference name. Now whenever we will use the variable named name, we will get the value Yash. Another example, age equals to 16. What happens here? Again, a reference will be created and the name of the reference will be age in this case, and it will be pointing to a memory location where the value 16 is stored. So it is very simple here to declare a variable. In this case, the name variable is of string type because it is storing string variable value, and in this case the age variable is of integer type because it is storing a integer value. So this is how simple it is, right? Now let us consider the situation that will be happening in memory, that what will be the memory representation, what changes will take in memory of a computer the moment we declare a variable. Now once the variable is declared and assigned with some value, what happens in memory is you can simply understand by the concept of front-loaded data space. What happens here? Python uses the concept of front-loaded data space. It is simply a memory area where some commonly used data are pre-stored, 16, 17, 18, likewise. Means it is assumed that these are the values that will be commonly used during the execution of the program. So these values are pre-stored in memory. That is done by the Python interpreter, and this is what known as front-loaded data space, right? Now what happens? The moment we declare a variable, in this case suppose I have written val1 equals to 16. The moment we declare a variable and we assign a value to a variable, what happens? A reference is being created and the name of that reference is in this case val1, and this reference points to that memory location where the value 16 is stored. So in this case value 16 is stored at the location 102. So this variable val1, this reference val1 will point to the location 102 because it is containing the value 16. In another case, val2 equals to 23 I have written. So what happens here? A reference val2 is created, and because it has to store 23, then what will happen? It will point to a memory location which is having the value 23. That is, val2 will point to the memory location 180 in this case, right? So it is very much clear here that the variable does not occupy any space in memory. Variable is simply a reference. What occupies space in memory is the actual value. These are the actual values which are occupying space in memory, right? Now consider one more example. Val1 equals to val2. This is the third statement. After the first and second statement, this is the third statement, that is val1 equals to val2. Now what happens here? Val2 is having a value val23, right? Val2 is having a value 23, and this val2, that is 23, is assigned to variable val1. Now what happens? Initially val1 was pointing to 102 location which is having a value 16. Now it has to store the value 23 in it because val2 is having 23, so val1 should also have 23. Now what will happen? Here value will not change of val1. Instead what will happen? Now instead of pointing to 102, this val1 will now start pointing to location 180 which is having the value 23 in it. See here, val1 is now pointing to the same location that is pointed by val2, right? Means 180. Now val2 and val1 are having the values 23. Both are the same values right now, right? So it is very much clear that a single value, in this case 23, can be pointed by multiple variables, right? So in this case, both the variable val1 and val2 is pointing to the same location, that is 180, which is containing the value 23, right? Now consider a situation where the variable is first assigned with one value, and in the very next line of code it is updated and assigned with some other value. Now what happens here? Here the reference is now shifted. Here the reference is now shifted Now it points to another updated value in the front loaded data space, right? Look here. The moment we wrote x equals to 10, x was a reference pointing to the location 102, which was storing the value 10 in this case. The moment we updated the value of x, that is x equals to x plus 1, what happens here? The previous value of x was 10, 10 plus 1 goes to 11, and the x is reassigned by the value 11. Now, in this case, here the value of 10 will not be updated to 11. Here, now x will be shifting to some other location. X will start pointing to some other location where the value 11 is stored. So in this case, the value 11 is stored at the location 202, right? So the shifting of pointer will take place. Instead of pointing to 102, now it will point to 202 with a new location having a value 11, right? So this is the case in Python, and because of this feature, the primitive data type variables, that is integer, float, boolean, string, all these variables are of immutable types, right? These are immutable, means the in place value is not changed, right? The in place value is not changed. Earlier it was pointing to 10, now it is pointing to 11, but at the location 102 the value is 10 only, right? So the in place value of a variable is not changed. Simply let us understand with an example of other language. Suppose it was a language C. In C, what would happen? The moment we write x equals to 10 in C, what happens? C programming language, a block will be allocated, the variable name will be x, and the value stored in this variable will be 10. The moment we write the next line, that is x equals to x plus 1, now what happens here? The value of x was 10, 10 plus 1 goes to 11, and it is restored in the variable named x, means in this space only the value 10 will now be updated to 11. This was the case in other languages, C, C++ and Java. But in Python, what happens? The in place value remains the same. Once the value is updated of a variable, it will start pointing to some other location. This makes the Python variables as immutable variables, right? And the mutable variables are those variables whose values can be changed in place, right? Something like this. If this would happen in Python, then those variables will be treated as mutable variables. And in Python, list, dictionary and sets are some of the examples of other data types whose variables are of mutable type. Okay, so this was all about mutable and immutable variable. Now in Python, multiple assignments can be done in a single line, right? Multiple assignments can be done in a single line. See here, x equals to y equals to 10. Now what happens here? A reference will be created and the name of the reference will be given as x. Another reference will be created and the name of the reference will be here treated as y. And both these references x and y will be pointing to a common location in memory that will be containing the value 10. Suppose the memory location is at 102, then x and y, both the references will be pointing to the location 102 which is having the value 10, right? So this multiple assignment is possible in Python. Consider another situation, x comma y comma z equals to 10 comma 20 comma 30. This is also possible in Python, where the assignment takes place from left to right, right? It takes place from left to right. So what happens? First, the value of the left hand side, that is 10, will be assigned to the x, then 20 will be assigned to y, and then 30 will be assigned to z. So this is the order of the assignment, that how it takes place. Okay, so it is possible, and the assignment takes place from left to right. So this was about multiple assignments. Now consider a situation. Suppose we have assigned the values of x, y, z as 10, 20 and 30. See, the x, y and z. Three references are created, x, y and z, and the values assigned to the variable x, y, z are 10, 20 and 30, right? It means x is pointing to the location which is having the value 10, y is pointing to the location which is having the value 20, and z is pointing to the location which is having the value 30. Now again, what in the next line we have written y comma z comma x equals to x plus y, y plus 2 and z minus 1. As I told, the assignment will take place from left to right. So first this x plus 1 will be evaluated and will be assigned to y. Now what is the current value of x? The current value of x is 10. 10 plus 1 will give you what? 11. And this 11 is assigned to y. Means now y will start pointing to a new location which is having the value 11. Right? Now this location will be cancelled out and the new link will be created and it will be pointing to a new location that is having a value 11. Now in the next step, y plus 2 will be evaluated. Now what is the current value of y? It is now 11. So 11 plus 2 goes to 13 and this 13 is assigned to z. So what will happen? Now instead of pointing to 30, now z will start pointing to a new location that will be having the value 13, right? So this link will be breaked and a new link will be created where z will be pointing to a new location in memory that is having the value 30. Now the third is z minus 1 will be assigned to x. Now what is the value of z here? It is now pointing to 13. So 13 minus 1 goes to 12 and 12 is assigned to x. So now x will be pointing to a new location in memory that is having the value 12, right? So after these three lines of code, the value of x and y and z are changed, means the references are pointing to the new location where x is pointing to 12, y is pointing to 11 and z is pointing to 13. So this is the logic. It is simply I have written here, I have explained here to understand that how this memory mapping is done and how the references are being created, so that in further programming you do not have any confusions, right? So this was about multiple assignment. Now another most important feature and interesting feature of a Python is that it is dynamic in typing. Now what is the meaning of dynamic in typing? Here dynamic typing simply makes variable more flexible in Python, right? Dynamic typing simply makes variable more flexible in Python. We can say that a variable assigned with one type of value, right? A variable assigned with one type of value can be reassigned with some other type of value in the same program, which was not possible in any other programming languages. In C, C++, Java, it is not possible. But here in Python, it is possible that a variable assigned with one type of value can be reassigned to some other type of value in the same program. See here, it is simply written x equals to 10. Now what happens? A reference will be created and it will be pointing to a location having the value 10. That is, it is having an integer type of value. So after this line of code gets executed, it is simply understood by the interpreter that x is pointing to a location in memory where it is storing the value 10, means x is of integer type. In the very next line, same x is now having the value Python. Now what will happen? This link will be break and the new reference will be created, and this reference will be pointing to a new location in memory where the value Python is stored. Means in this same program, in this same code, at a moment the x was pointing to an integer variable and now it is pointing to a string variable value. This is possible only in Python. This is not possible in C, C++, Java and any other programming languages, and this is what known as dynamic typing. So I hope you got this, and it makes more interesting right now about Python, that what is Python and how it is more interesting and how it is more simple. I hope you are getting it, right? Now, one more concept is of L value and R values. Okay. Now, simply just understand it here. Looking at this, x equals to 10. It simply means the value of 10 is assigned to x. It is a correct statement. When we write y equals to x, it simply means that the value of x is assigned to y. This is also a correct statement. But if we write something like this, 10 equals to x, is this a correct statement? No. It means that the left hand side value will always be a placeholder where you can store some value. Right hand side value can be a constant also and can be a variable also, which is having some value that will be stored in the left hand side, right? So this is what known as L value and R value. L value is simply a object to which we assign a value. Here in case x and y are the L values, left hand side values, okay? And the R values are the either literals, the constant, or an expression, or simply a name of a variable which is having a value that is assigned to L value, that is left hand side. So this is a correct statement, but this is not a correct statement, right? So this was all about L value and R value. Now this comes to the end of this video. In the next video, we will be discussing about input and output statements. Till then, take care. Goodbye.